Hi there, this is session 21 of programming from the very basics using Python. In the last session, I introduced you to a list and I told you how you can create a list and perform various operations on a list that involves slicing, dicing operations. And I also introduced you to a couple of list methods. I think I talked about insert method, I talked about append, I talked about extending a list, and I also talked about popping out items from a list. So I told you about four methods. I'll talk about some more methods in this session and also tell you about interesting things you can do with a list in general. So let's get started. So if you remember the last time I told you, last session that is, I told you that you can create a list. I think I lost the list I created in my previous session. So I will create some list with some numbers in here and 4, and let's try 2 and make it a little larger enough, and with some repeated items, of course. Yep, I've created a list this way using the little notation, of course. I told you that pop can be used to remove one item from a list. What if you want to remove multiple items? Well, you can't do with a single pop operation. Pop takes an index and removes an item at an index. If you want to discard slices of a list, I told you can use the del statement. Yeah, you cannot retrieve it into a variable or something. You can slice it and then delete it. Maybe for all I want to remove, let's assume 0, 1, 2 from the third index. Let's say 3 to 8, 3, 4, 5, 6, 7. I want to remove these items from a list, but I want to store it in another variable, right? Through another variable. I want to access it through another variable. So I can do that by using first b is equal to a of 3 colon 8 and then del a of 3 colon 8. That's what I can do. Can't be done in a single statement or an expression. If you know a way to do it, let me know. But this is what I can think at best at this moment. So if you now try to print A and try to print B, you can see that A has some items removed, and whatever items are removed is accessible still because you sliced it and got it in B, right? This is one of the ways you can achieve that. The next couple of methods I should also talk about is, apart from pop, if you want to remove an item from a list, not based on the index, but based on the value. Let's say I want to remove 56 from this list. I don't know where 56 is. So first thing you need to do is you need to find out the index of 56 and then pop it out from there. So you could actually do this. You could say a.pop of a.index of 56, right? There's one way to do it. And if you try to print A, you can see the first occurrence of 56 is removed. The 56 is no longer there. After 22, there is 78 here that you can see. 56 is removed. But you know what? You don't have to write an expression like this. A shorter way to do it, or a more intuitive way to do it, is using the remove method. You can use a.remove of 56 directly. Think of remove is just a shorthand for a.pop of a.index of an item. That's what it does, right? So this is more apt for removing items from a list that you don't need, but you want to remove it based on the value. You should also note that it only removes one item. First occurrence. 56 is removed from here, but there's another occurrence 56 somewhere here, which you can see. And that is retained, right? Let's see if there's a way to remove all occurrences. The one way to find out is you can just say a.remove and just open parenthesis. If you're using VS Code, it looks like there's no other option. Removes first occurrence of a value. Done. No other alternative, no options are there. You just need to pass the value there. And yes, if you pass a value that doesn't exist in a list, as usual, let's say I give 77. I don't know if 77 exists. I don't think so. Try running it. It throws value error, not index error, value error, because the value that you passed is not found in the list, right? So that's what you should know. Pop returns raises. Pop raises index error when you pass a wrong index. But when you try to do a.remove of a value, basically it calls a.index of 77 internally, which will raise a value error, of course. And that's what stops it from proceeding any further. Now, you might ask me, what if I want to remove all occurrences of a given value in a list. So I have a list here. And I want to remove all occurrences of this item, let's assume 56, from this list, both occurrences. Let me add much more. So I can just add 56 one more time here. And I'll add 56 somewhere else in the midst here. Let's say 56. Now there are many more items whose value is 56, right? We are like 1, 2, 3, 4 items. What if you want to remove all occurrences? Well, trying to do a.remove is not going to work. As you can see, it only removes the first occurrence. All the other occurrences of 56 still remain, as you can see here, right? So if you want to remove all occurrences of 56, you can't do it with a single method, unfortunately, as of now in Python. If you know a way to do it, let me know. But this is how you do it. Maybe writing a small algorithm here. Remember, all these are mutation operations. Some of you might say, how about using some kind of filter operation? All kinds of filters will create a new list. So that's not what I wanted. I want to remove it from an existing list without creating a new list, right? That's what the whole operations like append, insert, extend, pop, all do that. They modify the existing list. They don't deal with creating a new list, right? So if you want to remove multiple occurrences, one of the ways to do that is you have to write a loop. And one option is you could do a for loop like this. We can say for value in A, or you can say for value in A. But if I do that, it's going to work. Is it going to work? Is it going to work? No, it's not going to work, right? So if I just try doing this, it's not going to work. So I can just try. How do I formulate a loop here? I'm thinking. Okay, let's try this. You can just use for underscore in a.count of 56. Oh, I forgot to mention. I told you that count will tell you number of occurrence of an item in a list, right? It's same like tuple. Index and count, I think I covered when I talked about tuple. These methods are available also on a list. First, let me run that and show you. If I just use maybe a.count of 56 will tell you number of occurrence of 56 here. 4 occurrences. So therefore, you can do something like this. Maybe for underscore in range of a.count of 56. And then you can just do a.remove of 56. I know that this does not look Pythonic to me. It does not. But I'm going to leave a comment here. Not very Pythonic. And let me know if you can find a better way, which is more succinct than what I've shown you here, right? So think about it. So I'm going to leave it as a thought process for you people. So if you can find out a better way, let me know. Just post it on comments. So I think that'll be a great thing. Be great learning. All right. So I told you can use remove to remove just one item from a list. And what other method exists? Now there are 2 more methods I should talk about. Let's say A is equal to, okay, let's take this list, the same list which I had created earlier. It's large enough. Let me use that. What if I want to make a duplicate copy of a list? I want to make a copy of a list. B is equal to A. Should do it, right? Let me know. Does it actually make a copy of a list? Can I say B is equal to A? Well, let's find out. If I try to print A and B, right now because the list is long, I'm going to separate it with new lines. Sep is equal to /n. They seem to look like a copy, isn't it? But I told you about assignments. All assignments copy references, not objects. I think I remember telling you that. You should also note Python Zen of Python. Just import this in your Python prompt and you get the Zen of Python. Where there's one of these quotes. Okay, I'll just type it off here. If you just go to the Python prompt here and type import Zen, sorry, import this, you get the Zen of Python. There's one interesting quote here. It says, special cases aren't special enough to break the rules. All rules are consistent across the board in Python. Oh, just because it's a list, oh, assignment should work differently. Nope. Assignments, copy references. Doesn't matter what kind of objects they are, right? So even here, when you actually do b is equal to a, it's not going to do any different than any other assignments. So a and b refer to the same object. I'm going to prove it now. I'm just going to replace one of the item in a this time. I'm just going to type a of 2 is equal to some number. Let's say 1, 2, 3, 4, some number, some arbitrary number. Now if I try to print a and b, if I modified a, it should now be revealed in b, isn't it? Well, you can see that. What changes I made through a is revealed in b, because a and b are just two labels on the same list object. There's one list object. There are just two labels now. When I say b is equal to a, I added just another label to the list. So whether you modify a list through a or through b, you're modifying the same object. So you didn't create a duplicate copy with this. So in fact, the final proof for this is obviously the ID. Let's say try to print ID of a and ID of b. You can see that the object's identity are the same. The memory address in this case, both point to the same memory address. So how do I make a copy? Well, in traditional Python, that's before Python 3.0, there's some weird hacks being applied. I will show you one of them, which is to find a lot of Python code, and somehow I didn't like it. When I see that kind of code, I say, it gives me a very bad feeling. So what is that? I could try b is equal to a of colon. This works. Even now. What does a of colon do? When you use a slicing operation, slices, you're extracting a slice of a list. And what does it do? It creates a new list representing the slice. But now I tell Python, I want a slice of a. How big? Everything. I want everything. From the start to the end is my slice. What does it do? It doesn't just retrieve a part of a list as is and give you a reference to it or so on. It creates a new list with those items copied. So it actually creates a new copy. As you can see here, the ID is different. And this is how it is done before Python 3.0. In the Python 2 world, Python 1, I guess so, maybe Python 2, I remember. That's the kind of code I've played around a lot with all these levels, right? So you do this for copying a list. It's a hack. It's really a hack. But I would suggest not doing this in case you have the misfortune of working with very old versions of Python. Very likely, if you work in organizations or companies that maintain very old code base, written in the Python 2 days. Oh, there are a lot of that kind of code even lying around in various organizations I know of where I deliver trainings. And they still deal with Python 2.6 and 2.3 versions of code. Very old, ancient by today's standards. But unfortunately, that's how the industry is. So if you happen to work in such old Python code base, instead of doing this, you want to try this one out. P is equal to list of a. For all the old versions of Python, I would recommend this because this is better. I have sort of commented this code off, right? Shouldn't be doing it, but yeah, it's okay. I'm just going to leave it at this. But this is better for old versions of Python to copy a list. Maybe Python 2 or below. If you're using very old versions of Python, this is how we do it. But how do you do it in Python 3 onwards? Python 3, I'll tell you that Python as a language design is all about consistency and familiarity. There are familiar interfaces. When I use the word interface, it's like the ways you interact with objects. The interface is the means by which you interact with objects. So I'm using the term interface. It's a term used in the object-oriented world, but it's a very simple concept. If I want to invent a new mouse, because I have a mouse here, that's the only example I can think of. If I create a mouse that looks completely different than what is commonly available, the chances of people buying it, using it, is a little unlikely. I remember back in the days, I remember working in a very old company, a long time back. I think it's almost like 20 years back. 20 years ago, 22 years, 23 years, maybe, yeah, 23 years back. So back in 2000 era, I worked in a small startup company where my boss had a funny looking mouse, which looked like a globe, rotating globe. It's some brand from Genius, and the mouse movement is not like this. Not like you use your mouse and you point and click. You hold your hand on the globe and rotate that globe. And there's some buttons on the side, you click on it. You rotate the globe. Those days, mouse had a ball below. I guess you know that days. Maybe if you did programming or used computers in the 90s, late 90s or 2000 era, we didn't have this kind of mouse with this kind of lights in here, right? This is this laser mouse or whatever you call it. They use laser tracking. But the old generation mouse used some kind of a rotating ball, right? The ball just rolls over the mouse pad and that rotation is tracked. And that's how the mouse pointer moves. Having a small ball in the mouse, they had a big globe in one of these brands. It's a very outlier version. But that didn't sell. Not many people use it. It is also expensive. It can be mass manufactured. I'm just telling you that it's a very unfamiliar interface to something that people are not accustomed to. Imagine buying a car in which you no longer have a steering, but you're given joysticks to operate, like in some kind of a game or some kind of exotic sci-fi movies, giving you two joysticks to operate a car. You wouldn't want to buy that car, would you? No, because it's a new learning altogether. That's an unfamiliar interface. The Python world, whenever they introduce new features, they have made sure that if those features are something that's like an addition, an extension, right? They'll try to make that interface quite familiar. In the early versions of Python, there was a method called copy that was available in a dictionary, later on added to a set. We thought, oh, let's add it to a list. So let's make sure all mutable collections have a copy method. Now it's a common trait. If you have any collection that is mutable, all mutable collections, it could be a list, set, dictionary, and many more collections that you'll find inside collections module and many other places. They all have a common method called copy. All these objects have copy method to make a replica of themselves, right? So if you're using Python 3 and above, you're better off using this particular operation. You say b is equal to a dot copy. And this works. You still have three ways to copy a list, even today. The two ways are the old school ways, just there for legacy reasons, perhaps. And you can still use it, but it's always recommended that you use the copy method, if you can, to make a duplicate copy of a list. So that's how you can make a replica of a list that you can see here. It's a different object ID altogether. And this copy method creates what we call as a shallow copy. All of it. Whether you say list of A, whether you say A of colon, or whether you say A dot copy, all these three forms, which I just mentioned now, they create what we call as a shallow copy. And now what exactly is a shallow copy? To understand shallow copy, we should go one level deep. I should now talk about lists with lists inside them. Let me show you a simple example for now. When I say A is equal to 10, I'm going to create an inner list here, 20, 30, and I say 40 here. How many items are there in the list at this moment? Well, you may think there are 4 items, but actually there are 3. I can show you that. Let's say print len of A. There are 3 items in the outer list. One item is 10. The other item is the inner list itself. And then there's the third item, which is 40. I should also note that a list is a collection of references. So is the case with a tuple, list. I wouldn't say that for a set mostly, but yeah, set does have references, but it's a more complicated thing to talk about set at this moment. But it's in a way it's like a reference. It's still a reference, right? List, tuple, set, and even a dictionary. They're all ultimately collections of references. To understand that, I need to go back to my diagramming tool, which I'm using, draw.io. When I create a list like this, let's say list of 10, 20, 30, 40, right? There's an inner list here. This gets constructed first, and that's done like this. A list is an object. A list is an object. Let me call this list here. And every list has an array inside. A list has a dynamically growing array, an array that sort of grows dynamically, which is maintained and managed internally. We don't get to access it from Python, right? It's implemented in C. This array at this moment has three valid indices, index 0 and index 1. What those array slots store are the addresses, or rather the IDs of objects they represent. So when you create a list with values inside them in Python, like list of 10, 20, 30, the values are not stored inside the list. They're not boxed and stored inside it. It gives you that illusion. But rather, a list is like its own ledger or register, which has got references to the values around in memory. So actually, these two numbers are created. You know that they might already exist in memory. That's got to do with small numbers, but let's not consider that for now. So let's say there's 20 and 30 somewhere in memory. I'm going to 30 first because I want to put it in that order. Sorry about the small font. You'll live with it. And there's another value which is 20 that also is located somewhere in memory. The 0th index holds the address of 20 or the object ID of 20. And the first index holds the ID of 30, the object ID of 30. This is how the inner list is constructed. So think of a list as some kind of a roster or a ledger. Let's say there are people walking inside the room, or maybe you're in a classroom. I want to track how many students are there in a classroom. One way is I have a roster. We call them as the register, maybe attendance register or attendance roster or something. What do we do there? We don't take those participants and put them on a sheet of paper, do we? No, we don't. That sheet represents a collection. That's a collection. We have the names. 0, first index. We use numbers starting from 1. Let's say 1, first participant. 2, second participant. 3, third participant. And we track them, right? We store each one's address. For us, the address could be the name, the employee ID, or the student ID, and whatever, right? That's how it is. A list is pretty much like that. So when you try to store items in a list, those items are objects in memory. Those items' addresses are stored in the list. So if you're a C programmer, if you come from C background or a C++ background, you can sort of relate a list sort of like an array of pointers, array of addresses to other data structures. And that's exactly what a list is in Python. The same goes with tuple. Even tuple is just the same. Only difference is that once a tuple is created, you can't change those pointers. These pointers are fixed. There's no way to modify them. That makes it immutable. But list is mutable, so you can change them. You can change those pointers to point elsewhere. You can add new entries. New slots can be added. The array can grow. You can allocate more arrays and map them. It's a vector algorithm, which we'll discuss at a much later stage on how it's implemented. But this is what you should know. Now this is the inner list. And now you have the outer list, which was the outermost, which you see here. 10, the inner list, and 40. So how does the outer list look like? The outer list looks like this. This has 3 slots. Let me just copy these two to save time. there is 0, 1, and maybe there's another slot, which is 2. I don't know why this came up. Sorry. Yep, wrong keystroke. The 3 slots in the outer list, and the 0th index would point to a value, which is an object indeed. Maybe an object somewhere in memory, let's say 10. It can be located somewhere in memory, and 0th index holds the ID or the address of that object. And the first index that you see here, the first index refers to this entire list object. This list is an object in memory again, which is holding some inner arrays, which is having address to other objects, right? This list lives in some location of memory. So this first index holds the address of this list, the ID of this list. I use the ID address, it's all the same in C Python, right? So object's ID is the location of the object in your default Python implementation that you get, the official Python implementation as of date. So I can just copy this here. Let's call this, there was another number like 40, right? So 40 was the last item here. So the second index represents, the index 2 represents 40. This is the memory layout, a very rough memory layout of how things are organized when you create a list of lists, just like I did here. Now, obviously, when I say len of a is a variable, I'm going to keep it simple this time and put some variable like this. Let me move it on this side a bit. Yep. Let's say this is a. It's an identifier. That kind of refers to this list. A refers to a list. That list has 3 slots, 3 pockets in arrays that are valid. The 0th index of that array holds an address of 10, which is another object in memory. The first index holds the address of another list, which also is an object in memory. And the second index holds the address of 40. That's the outer list structure. The inner list in turn again has 2 slots, 2 pockets, I would say. 0 index 0 represents address of 20, first index 30. Now some of you want to ask, how do you access inner list contents? I forgot to mention that. If I print a of 0, you get 10. If I try a of 1, what do you get? You get the entire list, because you're returning reference to the list. This the index 1 refers to inner list. That's what is returned. You get the entire list. But no, I don't want the entire list. I want to just get an item of that list. How do I do that? I can do multiple levels of subscripting as long as it's valid, right? So you can say a of 1 represents a list. Because it represents a list, I can further subscript it and say get me the 0th element of the list being returned. This is how we can nest through multiple levels if you want in a list. And there's no limit in how deep a list can be. A list can have a list, which can have a list, which can have a list. It can go as much as you have enough memory on your computer. Or you didn't hit any of these special barriers like the 2 power 64 or 2 power 32 barriers. 2 power 64 is hard to hit, but 2 power 32 maybe. Those are these programming language limitations sometimes, design limitations. But mostly you will not hit to that ceiling. You can go to any levels as you can, practically. You can nest a list as deep as you want. You can have a list that can have a tuple, that can have a list, that can have a dictionary, that can have a set, that can have further another tuple or a number. You can go n level deep. We'll talk about nested data structures in a specific session, but I talk about how do you structure data. And I finish with even dictionaries. Few more sessions, right? I'll go to that depth after a while. But for now, this is what you should know when you're dealing with the list. Now coming back, I told you that this list is created like this. When you say B is equal to A, we did that first. B is equal to A. What really happened? It creates another label, B, which ends up referring to the same list as A, which means that B is referring to the same outer list. And that's why when you alter A of 0 to represent something else, let's say if I say A of 0 is equal to 100, what really happens? 100 is another object. Let me just represent that as another object here in memory. 100 is just another object. And the 0th index is now going to store the address of 100 or ID of 100, that integer object that is representing 100. So it goes here. Sometimes this tool is like a little painful for me to use it. Yeah, I need to. Okay, never mind. So 0 no longer represents 10, it represents 100. So when you say a of 0 after that, you get access to this object, not the earlier one, because 0 holds a reference to new object. This is what happens when you assign to a list. List item assignment is what happens internally. Slice assignment is also the same, it's just a little more exotic. It doesn't just assign to one item, it assigns to a series of items based on the slice that you select. When you delete elements, of course, those slice, that particular part is removed and maybe shuffled across if necessary. All the other elements could get reindexed, right? That's what happens. So this is what happens. And assuming that 10 has no more references, it would get garbage collected. But we know that small numbers are interned, so they don't. The number was not 10. If it was like 5,000 or 10,000 or something like that, yes, it would have been garbage collected, assuming there are no more references to this object. That is very likely. When I say b is equal to a, this is what happens. But instead of telling b is equal to a, if I say b is equal to a dot copy, let me go back to the old form. Let's leave it at this. I just explained it. It's in the video, so fine. I think I'm not going to be sharing this. Instead of telling b is equal to a, if I say b is equal to a dot copy, what really happens is a new list is created, which is an exact replica of the existing outer list. It replicates outer list. That's what copy does. Copy copies this entire object. When you copy an object, what really happens? This entire list construct is copied here. The list structure is copied, the object structure. As a part of this copy, all these references are also copied in here. And B ends up pointing to this. But because these references are also copied, what really happens is, I think I'm losing a little bit of screen real estate in here. I'm sorry about that. Let me just try to increase it a bit. Yeah. Because you're also copying the references in here, whatever address 0 points to, 0th index points to in the first list, the 0th index will also have the same address, which means that this will be another reference to the same object 10. That's how it is. The first index would end up pointing to the same inner list. And the last index would end up pointing to the same value, that's 40. I know the whole thing got a little too messy. Okay, never mind. But I guess you get the picture of what I'm trying to imply from this. Right? Let me just, yeah, okay. So all these objects get other references. One to note is the inner list. That is not duplicated. This is what you mean by shallow copy. So what is shallow copy? You're only copying the outer skeleton. That is, you're copying the outer structure, not the inner. You're not copying the inner list. You're making duplicate copy of the outer list. The inner data structures, if it's a list, dictionary, tuple, all other collections which could be there, they're shared. They're shared by these two outer lists. Now, if you do this, let's try. I'll copy the cell for now. And I say b is equal to a dot copy. I'll print using format strings. A is equal to and b is equal to. This is a and b. Let's actually separate them with. Oh, okay. Yeah, I use format string. So therefore, I'll use a new line inside. They're not two different arguments, so they are just formatted in the same string. So I can use /n inside. You can see there are two lists right now. The IDs are different. If you print the ID, A will have a different ID, B will have a different ID because the outer lists are duplicated. That's what copy does. But of course, if you now try one test here, A of 0 equals 100. And now we try to print both A and B, the contents of them. You know what? I want to separate this first set of prints to a second set. So one way to do that is I'm going to put print, and I'm just going to put some hyphen here into 40. String repetition, useful, right? Yeah, nicely demarcated. I drew a boundary here. So it's the first print where A and B are looking identical. But the moment I say A of 0 is equal to 100, what you modified in A is not revealed into B, because you just said it's like this. Now you made a copy, right? You made this copy. The moment you say A of 0 is equal to 100, another object called 100 is created. Or maybe it exists, let's assume small numbers. They might already exist and gets a reference to it. And A of 0 now points to this object instead. You can see that A of 0 points to 100. What about B of 0? It still points to the old value, it's 10. That's what happened here. A represents 100 for the 0th index, and B is still pointing to the old value, that's 10. But if you try this, maybe I'll just copy this whole code across. One more time. But instead of typing A of 0 is equal to 100, if I say A of 1 is the inner list. In the inner list, 0th index is equal to 200. The inner list I made it 200. Because the inner list is shared by the two outer lists. Do you see the effect of shallow copy? The copy method of all mutable collections in Python by default do a shallow copy, all of them, right? So you say list.copy. When I cover set in the future sessions, the next session perhaps, or maybe a session after that. So you'll see that set also has a copy method. It'll do a shallow copy. If you try looking up a dictionary also has a copy method. And that makes a shallow copy. If you have deeply nested representation of other collections within a dictionary's values, they'll all be shared. If you modify some inner elements, which is sort of referred through from a dictionary, you'll see that's shared by all of the dictionaries that are copied, right? This is a default behavior for all copy implementations of all mutable collections in Python. But now you might wonder, no, I want to make a complete backup of this list such a way that any changes you make into A, no matter how deep, how nested you go and make some changes, I don't want the changes to be leaked into the copy. The copy must be separate. I want to make a complete backup. We call that a deep copy. Deep copy. So this is a shallow copy, right? The dot copy method always performs a shallow copy. Always. Now, if you want to make a deep copy of this entire list, you might think there should be a method, but funnily, there is no method on a list. It is implemented as a generic function, and you see that in a module. So for all I want to make a deep copy of a list, I'd say from copy module, there's a function called deep copy. There's a module called copy in the Python standard library, and it has mainly two functions. One function called copy, which is intended for doing a shallow copy. Another function called deep copy. If you see how I've used the module here, I didn't say import copy. If I say import copy, I had to call it like copy.deepcopy. It doesn't read nice. Deep copy, the name is intuitive enough and is quite unique. It's very unlikely that you'll find a function called deep copy in any other module. That's why I'm using from copy module. I'm only interested in deep copy. So now, instead of using a.copy, I can just do deep copy of A. Deep copy is a function available in copy module. I just imported the function. It's a generic function, right? So the deep copy function performs a deep copy, as the name suggests, of any Python mutable object. I use the word mutable object here to be a little cautious because there are many immutable objects where making a copy does not make sense. Even a deep copy might not make sense. So that's why I say it's mostly meant for Python. I'll just avoid the confusion. I'll just say Python object. There are chances. There are some custom immutable objects that also you can apply deep copy on. But this is what it is. So deep copy performs, as the name suggests, deep copy of any Python object. So you can pass any Python object to it. It works, right? So when you do this, now you can see what changes are made to the inner list in through A is not revealed in B because B gets another copy. So deep copy will walk through the list nested and make replicas of all the inner collections that they refer to. No matter how deep it is, it's going to do it. And this is a difference between using deep copy function, which is a generic function, versus copy method. Now, some of you who come from backgrounds like Java or even normal beginners might have this confusion about methods and functions. How do you decide something has to be a method and something has to be a function? If you come to the Java world, especially, for example, length, finding out the length of an array, you say array.length. String.length. I think one of them is a method, the other one is a data attribute. Confusing. Leave it. Okay. So these are like attributes of an object. You say string.length, array.length. I think this kind of things are found even in nice languages like Ruby also, where they're all methods. But in Python, len is a function. Print is a function, which is supposed to be a method in languages like Java. You say system.out.println. I remember C# had a console.writeln. So you have an object on which you have a method. You don't have any outside functions in there. Python has both functions and methods. What is the rationale behind it? When should you use a function? When do you design a function? When do you design a method? Functions are designed to be generic. And almost all functions are designed to be pure functions. I'll talk about that a lot later when I talk about functions as such. But right now, it's suffice to tell you that methods are specialized for an object, right? For example, like in real world, methods are found in all the real world objects. Like this mouse, I have a mouse in front of me. So that's the only example I can think of at this moment. Has some methods like left click, right click, scroll. These are methods which are specifically for the mouse. You cannot do that kind of left click, right click on a pencil. This also is an object. I have another object called pencil. A pencil has method. Maybe you can do sharpen, write. And that's the only thing I can do with a pencil, I guess. There's no cap, nothing, right? You sharpen the pencil and you write with it. Sharpen and write. These are only methods on this pencil. Whereas you shouldn't be sharpening a mouse. I don't know there's a way to sharpen a mouse. Why do you want to sharp? You want it to have it as curved as possible, right? And yeah, this left click, right click, which doesn't work on a pencil. You can't take a pencil and do. It doesn't make sense. It doesn't work. But this does have an effect. It changes the state of the mouse. All these methods operate on the state of the object. They manipulate the state of the object. They either get or manipulate the state of the object. That's what they do. So writing with a pencil will make this lead blunt. I have to sharpen it after a while. And I sharpen the pencil size drops. Eventually, it will become too small that I have to throw it. Right? That's how it is. It changes the state of the pencil. Right? So methods are designated to be or designed to be specialized on the objects they work on. They manipulate the state of the object. That's what methods do. Methods are functions. They're actually functions, but they are tied down to an object. They're tied down to an object state. Right? That's what they are. So whenever you use a method, you always say some object.method, like list.append. You can append to a list. You cannot append to a set. You cannot append to a dictionary. You cannot append to a tuple. You cannot append to a string. You can only append to a list. It's a method that operates on a list alone, changing the state of the list. It adds a new item to a list, growing a list, right? But don't copy. Copy method is a list method. It sort of creates a copy from an existing list. It's a shallow copy though. Deep copy is a function. Functions are like super generic actions you can perform. Like I can lift this mouse, lift this mouse. I can lift this pencil. I can throw this mouse out of frustration. Maybe this mouse doesn't work. I can just throw it. I can throw this pencil out of frustration because my code doesn't work. My algorithm doesn't work. I'm frustrated. I throw this pencil. Lift, throw, buy, sell. These are generic. They don't care about what objects they are. Each object might respond differently to them, but you can apply this as a generic function on any objects around my room. Or maybe you can see some people get so frustrated, take the monitor and throw the monitor out. I've seen one of those YouTube videos. Person just wriggling his CRT monitor and throwing it out. An interesting meme, right? So, throw, buy, sell, lift. These are functions which can work on any object. If you're a purist Java person, you say, no, it's wrong. You will say, person dot lift of mouse. Person dot lift of mouse. Lift is a method of a person. Buyer dot buy of pencil, maybe from a seller, whatever. That's how it is. They'll try to boil down everything as methods. That actually introduces some amount of rigidity. It's purist. It looks very pure. That's why you have a system.out.println in Java. Not println. System.out.println, because you can't have a function hanging in the air. It has to be a method tied down to an object or a class if you prefer. That's even complicated. It's not where you talk about that now. So that's how it is. The Python world, the Zen idiom says, although practicality beats purity. When you talk in real world, you don't say person dot lift of mouse. You say lift that mouse. Based on the context, you figure it out. Oh, lift that mouse? Yeah. Give me that mouse. Give it to you. Java person, you dot give me the mouse. Right? You can see that. It's more verbose. It's more explicit. It's super explicit. But sometimes it adds more amount of headache for programmers to type it. So yes, then I made some design considerations in Python where if at all a function is designed to work on different kinds of objects, right? Different kinds of objects. They make it a function rather than tying it down as a method on an object. Some of you might argue, what about len? Len should not work on an integer, right? Try it out. I can throw a mouse, I can throw a pencil, but I cannot throw this table. I can't. The table will raise an exception. Or maybe I throw a mouse, maybe it'll pitch. I throw my smartphone, it will break. That's bad. So some objects will respond positively, some objects will raise an exception. That's it. I remember a very funny joke I can think of is when it's about 25 years ago, when I have a brother, an elder brother who had a son. Was very young, very, very young, and very mischievous at that. At this timeline, when during the night time, when he's supposed to sleep, he doesn't sleep. Everybody are falling asleep. Everybody are like drowsing, and his person is like super active. He was like 1.5-year-old, 1.5-year-old, and he goes patting everyone. Everyone is sleeping. He's patting them. He pats his father. That's my brother, and my brother just says, "Okay." He pats my mother, his granny, and he patted me, and I woke up and slapped him. Exception. Now he knows that he shouldn't pat me anytime. Right? It's a joke. So anyways, I'm just trying to tell you that there are functions which seem to be generic, and different objects will respond differently. Some objects will respond positively. You work with that. Some objects raise an exception, and you handle that exception. That is how things work in the Python world. You will learn more about it when I cover duck typing as a dedicated topic in a session. Okay, I digress. Let's come back here. So I talked about deep copy, and I told you why it is a function and what does deep copy do. Deep copy makes a complete replica of all objects. That includes All Python objects. You can actually make a deep copy of a dictionary, deep copy of a set, deep copy of a tuple that is nested in nature. All Python objects can be deep copied, right? So this is what you should know about copy versus deep copy. Shallow copy, deep copy. The concepts that you remember. Now that I told you about copy method, there's another interesting one. Another method on a list. With this, think about it this way. Let's have a list here. Okay. Type in the wrong keyboard. Let's have a list of 4 values. I want to empty this list. You know what a beginner mistake is to empty this list? Very simple. You want to empty a list, A is equal to, empty. Isn't it? Did it really empty the list? No. A was referring to a list that had 4 items. When you say A is equal to empty list, you made A point to an empty list, but that list is not emptied. That list is not emptied. Real proof. If this had another reference, this list had another reference. B is equal to A, B is another reference to A. Now you try to say A is equal to empty list, but before that, let me just try to print. Can I copy it from somewhere? Yeah, I can copy it from here. Let me copy this across and show you. I say A is equal to empty list. And then try to print A and B. I'll also need to add this line so it looks more intuitive in the output. So let me do that. I'll add it here. Yeah. So I said A is equal to a list. When I type B is equal to A and B both refer to the same list. We learned that just few cells ago, right? When I try to type A is equal to an empty list, you're making A point to a new list that's empty. Rather, you're not emptying an existing list object. So because B still holds all those values, B still refers to the old list. You can see all old values. But maybe this is not what you wanted. Maybe you have a list that's being referred to by multiple referents. Many identifiers or entities are referring to the same list. And I want to empty that list that's being shared by multiple parts of your code. I want to empty that list. This won't help. This doesn't really help. How do you empty it? The traditional way to do it, the traditional approach in the Python 2 world was, you could actually do this rather. You type del A of colon. I told you del works with a slice, but this time it's a del slice of a list. How much? Everything, right? So this is one of the ways to do it. And when you run this now, you can see that both A and B refer to the same list and both look empty, right? So this works. But then if you're using Python 3, this could be a little unintuitive, and this is a statement. So if you had to use like an expression, you can't. Maybe you want to functions. All functions and methods can be used in right-hand side expression. Whether they return anything or not, it may be sometimes irrelevant, but you can't have the flexibility with del. That's one limitation. So in Python 3, they introduce a generic method that works on all mutable collections, and that's called clear method. Ouch. The pencil across. Error clear. So clear method does exactly what it did earlier. This is for old school way to empty a list. Python 2 or below. What is a modern way? You always use clear method. The moment you say list.clear, the result is exactly the same. This will empty an existing list without making you point to a new empty list. Note the difference. And that's exactly what clear does. So now that we learned A lot of methods by now. Was it a lot? Not really. You can remember 10 names, can we? We can remember 10 names. Ask you to remember, recollect 10 names of your closest friends. Maybe you have more than 10 friends. You can remember at least 10 people. Or maybe 11, or maybe some people maybe up to 15. 20 is the average number. With some difficulty, you can remember to 20 members. A list has 11 methods. You just need to remember those 11 methods. So far, I covered 9 methods. If you had counted me do it, 2 more methods, and then I'll wrap it up, summarizing all of them. The last 2 methods are sort of familiar if you know about some of functions I talked about. Remember some time back, I think in the previous sessions, I talked about iteration helpers. Was it session 16 or 17? I'm not sure. One of these sessions. But just recollect. If I use a list here, and now if I try for value in A, this is how I iterate over a list. Interesting. I never iterate over a list in the entire sessions, have I? No. It's obvious. List is iterable. You can always use it in a for loop. It's pretty standard thing to do, right? You can iterate over a list like this. But if you want to iterate over a list in the reversed order, what do? You type for V in reversed of A. Reversed is a function that lets you iterate over a sequence collection in reversed order. We learned that in the iteration helpers. I showed you with a tuple, perhaps. Also, maybe I gave you some examples with the list, and you can see that again, it's a recap. But you should note that reversed does not reverse an existing list. Let's say B is equal to reversed of A. I'll try to print A. A is as is. Or you might think B is a reversed copy of a list. Well, is it? Let's find out. Print B. List reverse iterator. Not a list. It's not a list. It's an iterator. I talked about the iterable and iterators. What do you mean by that? A list is an iterable object. The act of calling reverse function extracted the reverse iterator. Remember the library and the librarian example I talked about in the session where I talked about iteration helpers. The library is a collection of books. And the librarian is a person who can get you a book from there, one at a time, when you ask for it. Right? So that's what this is. There are 2 iterators in a sequence. You have a normal iterator that lets you iterate from start to finish, and the reverse iterator that lets you iterate in the reverse order, from the last to start, from the finish to the start, backwards, right? That's what you get here. So maybe you want to reverse a list in place. If you want to reverse a list in place, this is what you do. You can do a dot reverse. And now you try to print A. It's A, the same list, items are shuffled to be in the reverse order. It does not create a new list. So what does reverse do? Reverses a list in place, does not return anything. Make a note of it. Does not return anything. Now, the most common mistake that people do is this. I've seen this quite often, and I've done it. Comes from a habit of using Ruby before using more of Python. Before I did a lot of Python coding, I did a lot of Ruby coding, by the way. And in Ruby, it's natural to do something like this and try the same in Python and just to be frustrated and wondering why this doesn't work. What is that? For v in a dot reverse and print v, and you'll be greeted or rather surprised with an error. And the error says, type error, none type object is not iterable in this line. What does that mean? A dot reverse returns none. It's a function that doesn't return anything. I mean, it's a method that doesn't return anything. And when you use that in the right hand side expression, you get none. V is equal to none, and you cannot iterate over none. It's not V is equal to none. It's a none object. You expect the for loop expected an iterator, but it got a none object, and it tried to see that. Can I call next on it? Obviously, none object does not have any mechanisms to iterate. It's not an iterable object, and that's what happened here. So you should know exactly when to use reversed function, when should you use list.reverse. You don't want to iterate over a list, but you want to shuffle a list, transform it in the reverse order, rearrange the items in reverse order. Then you call list.reverse. That's it. It's a method that is intended to be used as a statement like print. You don't want to use it in right hand side expression ever. Using it in right hand side expression gives you no benefit because it returns nothing. It returns none. Right? You should know that very well about list.reverse. So if you want to really iterate over a list in a for loop, you should use the idiom that I showed you here instead. Reversed of a. The reversed construct can take any sequence as an argument. Could be a list, could be a tuple. It will not work with the set, by the way. List, tuple, strings. These are sequences. You can pass them and it'll let you iterate in reverse order. And it does not modify the list. The list is still left as it is intact in this case. The list is not modified, but lets you iterate from the finish to start, backwards. I talked about list.reverse. I talked about reverse. They're reversed, right? It looks like whatever. Yeah. The next thing I should talk about is what if I want to make a reverse copy of a list? I don't want to iterate over a list in reverse order. I don't want to transform an existing list. Let the list be as is, but I just want a reverse copy of it. How do you do that? Well, there are no functions. There are no methods to do it. But there's a trick, which I didn't cover as yet. The magic of slicing. If at all I have a list like this, if I try to use B is equal to A of colon, it's a duplicate copy. It makes a copy, right? I'll print A and B. You can see that. But if I try to do this, if I say A of colon minus 1, special step value minus 1, what you get would be a reversed copy of a list. If you observe about string methods, I didn't cover all the string methods. I covered the important bits. But if you have time, just go and have a look into all the string methods. You'll find all kinds of methods, but you'll not find a method called reverse. There's no string.reverse or string.reversed. Reversed of a string will give you a string reverse iterator. You won't get a reverse copy of a string. What if you want to get a reverse copy of a string? Same trick, right? That's what you do. So this would returns a reversed copy of a list. Remember, this operation works on all sequences. Just a detour, but I just forgot to cover this in string, so I'll just cover it now. It's a very interesting academic level exercise, and that is find if a string is a palindrome. How do you check whether a string is a palindrome? Or if you're a C programmer, you'll create a character array to represent a string, and you have one pointer in the beginning, one pointer at the end, and you'll try to increment one pointer, decrement this pointer, compare these two characters, and whatever mess. Complicated. Now we do it in Python. You don't need any complex algorithm for it. Let's say I have a string. Yeah, I can think of a language in India, Malayalam. That's a language in India, in South. Kerala. That's the spoken language in Kerala, the native language of Kerala, by the way. And this is a palindrome. How do you know that? You can spell it from left to right or right to left. They spell identically. Palindrome. You can reverse it. You can spell. It spells the same way. Or maybe there are a lot of English words. I can't think anyone very quickly, but E-L-L-E. L-E. It's a palindrome, right? So how do you check if it's a palindrome in Python? Very straightforward. A equals A of colon minus 1. Here you have it. One-liner. This is what makes Pythonistas people with superpower. What the C programmers punch on the keyboard, writing complex algorithms, and Pythonistas will just do it like this. You can see the magic of all these ingredients that make up your program. You can actually make your code very succinct, more practical, right? So that's what it is. So anyways, so talk about how you can do three kinds of reversal. If you want reverse iterate over a list, I told you to use a reversed construct. Pass a list as an argument and use in a for loop. I showed you that in the previous cell. If you want to make a reversed copy of a list, use the slicing operation like this. If all you want to reverse a list in place, I don't want it to return new list or anything as such, you do list dot reverse. You know these three forms of reversals when you're dealing with a list, right? The last method is talk about is the sort method. I guess you know that. If I have a list here, let's take a list which is unsorted. Let me go back to the earlier cells where I created that long list of very, very random numbers. Let me just take that. Sorry, going back. Wow, I covered so many cells. Let's take this. I have a list here. I want to iterate over the list, but in sorted order. I told you how it can be done with the tuple, isn't it? Same rules can be applied for a list. I can say for v in sorted of it. Sorted is a construct. It's actually a function. Okay, it's a function. It's not some type or anything. Sorted is a function. It's a proper function. So I say for v in sorted of a, and print v. I'm just going to put end is equal to space for now. I don't want too many vertical values being printed. I want to print it like this, horizontal. So it iterates over the list, but in a sorted order. You should note that sorted does not return any special type. The return value of sorted is always a list. I think I told you that, and I'm not sure if you can find out why. If you know the answer why it returns a list and not some special sorted iterator type or something like that, let me know in comments. Right? I want to know your answer. Just find out. So, but here is it. This is a b is equal to sorted of a. Remember, sorted does not modify the original list. The original list is still intact. You just try to print what a is. Still, that's a good old list. I'll just put it in a separate line. If you want to add a blank new line, the last print would add a space. That's why the next print added right after that. So if you want to add a blank line, you can just call print with no arguments. It adds a blank new line. And you can see that. The original list is left intact, but when you iterate over it, you're able to iterate in a sorted order. But sometimes you want to get a sorted copy of a list. You can just simply say b is equal to creates a sorted copy of a. I hit this for a completion. It's a print a. A is left intact, but b is a sorted copy. So you can use sorted function to either iterate over a list in sorted order because it returns a list ultimately, which you can iterate over. But if you just want that sorted list out of an existing collection, which is unsorted, you can call sorted of a and get a list which is a sorted. Remember, the return value of sorted is always a list. Even if you pass a tuple, even if you pass a string, the return value is always a list. Small trivial things to know about. Okay. But if you want to sort a list in place, by now you should have guessed it. Yeah, you should have guessed it. Sorry, you should have guessed it. So I have a list here. I have a list here which is sort of scrambled across. The values are not in sorted order. But you want to sort a list in place, I can just type a.sort and print a. A is now transformed in sorted order. Just like list.reverse, list.sort does not return anything. It sorts a list in place, returns nothing. So you can't use it as a part of an expression and expect anything out of it. You'll get none, right? So that's what you should know. So I'm just going to type it out here. The dot sort method sorts a list in place, arranges in ascending order, right? In place, and returns none. It is not suitable to be used as a right hand side expression. It's wrong to say B is equal to A dot sort and expect B to have some list in sorted order. A is sorted. You won't get anything in B, right? B will be none. But if you want to get a existing list as a copy in sorted order, then say B is equal to sorted of A, like I showed you in the previous set, right? So this completes all the methods that you should know in relation to a list in Python. Let me summarize the methods I covered from the previous session till now, till this moment. So the methods I covered were, let's put this as list method. Let me make it a markdown. I think it makes sense to make it markdown. I'll just call this list methods. Let me use a unordered list, let's say, bulleted points. The first set of methods I talked about were insert, dot insert. Just putting a dot insert indicates a method, right? Dot insert, dot append, and dot extend. Hint, all these three methods grow a list. They add an item at the end, or they grow a list by taking elements from another iterable. The next set of methods that you should be aware of is dot pop and dot remove and dot clear. You know what they do? They basically reduce the items in a list. One of them just pops out an item based on an index, another one by value, another one just empties a list. List shrinks in size by these methods. 6 methods so far. The next methods are some obvious suspects like index method. That is a common sequence operation. And then you have the dot count method. And there's something that's list specific. I'll leave this as one set, which is common sequence operations, right? And there's another 2 methods. Let's talk about dot copy. And you have dot sort. And dot reverse. 3 methods actually. So these are all the methods that you can apply on a list in Python. Very refined, but it's very powerful. You know, your methods are very few. You have just 11 methods, but a lot of things are done with slicing operations, operators, and many things. You know what really got me used to Python from a language which I like the most, Ruby, which I unfortunately don't use as much these days, right? I don't even train much on Ruby because I don't get a lot of training requirements in Ruby in the corporate world. When I get a Ruby training, it's mostly Ruby on Rails. I hate it. Ruby is much more than just the Rails framework, by the way. I like to see Ruby as a general purpose language. Now, sometimes I get Chef. I ought to teach Chef, not Ruby. Ruby is just a small thing there, right? But Ruby as a language is a fantastic language. Of course, I like it. So why am I talking in Ruby? But then, they're like 2 different worlds, Python and Ruby. Both are nice. Both are elegant. I would recommend learning both of them if you can, because it makes you think in 2 different perspectives in the dynamic programming world. You want to ask me what about JavaScript? Honestly, I don't like JavaScript, but sometimes you got to live with it because the browsers need them. If you want to be writing something for a web browser, it's inevitable. It's a horribly designed language, in my opinion. Right? There are more ugly bits in JavaScript than the good ones. That's me. That's my bias. Okay. So if I'm being subjective here. But anyways, but I'll tell you what is the difference in the thought process of Ruby and Python. So if you go to Python here, I will list, let's say an empty list for now. How many methods we learned in a list? Layer of A will show you all the attributes that includes the methods. You can for now ignore everything that starts with these double underscore. All these are dunder attributes. We'll talk about this in another session later on. Maybe I'll cover this more in object-oriented programming in Python. But the number of actual methods that we end up using are these 11 methods. You can count it. I categorize it there. On the contrary, you look at Ruby. Ruby also has a REPL. It's called IRB, Interactive Ruby. I say A is equal to B. Is how you create a array. It's called an array in Ruby world. It's the equivalent of a list in Python. It implements the same features internally. But the number of methods in this, you get to know by doing a.methods. And all of these are methods on a Ruby array. Wow. 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 If you want to find out how many methods are there, 197 methods. How many can you remember? You got to keep that Ruby documentation all the time because it doesn't map into your brain until you use Ruby all over your life, all through your life, which means it has a steep learning curve in order to know about every intricate details. So in summary, it's like programming in Python is like learning a very basic vehicle as such. Let's say in India, we have these scooters, we call them scooters. They're like two-wheelers, which are like very easy to learn and maneuver as long as you know how to balance those two wheels, which you would have learned via riding a bicycle. Using a scooter, the modern scooter, is quite easy. Ignition, the power on, rev the accelerator, zoom, it goes. And you apply brakes to stop. You don't have to worry about all the gears and clutch, right? Maneuvering the gears and clutch, that is very common, reminiscent of the motorcycles, right? I'm not sure. There are some motorcycles with automatic gears. I don't know about that. But the most motorcycles in India, you need to hold the clutch in one hand and tap on the gears and figure out when to use what gears, like 1, 2, 3, whatever. Or maybe if you use a car, it's like a car that's got an automatic transmission system. So you just don't have to worry about shifting gears, right? That's it. Python is that. It's very practical, gets you up to speed in less time, lesser things to learn and remember. Learning Ruby is like flying a Boeing aircraft. If you ever been into the cockpit of a Boeing aircraft, what do you find? Buttons all over, controls everywhere, controls. It's not like you just put in your keys, turn on the ignition. It doesn't work like that. You have to figure out what it takes to turn on the engine. It's a big course for people to learn, right? To become a pilot. That is the mindset. Yeah, some people say, oh, flying an airplane is a different experience than riding a bike. It might depend. I will not say that the language like Ruby is like super powerful or anything like that. No, you can do everything that do with Ruby with all these extra embellishments it's got on Python with a very minimalistic of features that it provides. All of it is possible, right? So there are two different thought process. There's like two different ways of looking at things. All right, so I think I will end this video here. So I think I'll move on to the next topic in the next session. I think the next topic is going to be more interesting. I'll talk about set, and then I'll introduce you to dictionary. Maybe some odds and ends about list. I think I've missed here. I'll cover that in the next session. And I know this session is stretched beyond an hour. It's almost like 1 hour, 20 minutes. So I hope you people enjoy what I covering in this video. And if you really learn something, if you really think that you find this video really worthwhile, please do hit the like button and do subscribe if you're not already subscribed. If you really like to know more of the concepts I cover, so you will get it on notification. And I will see you in the next video. Thank you very much.